In this lecture, we are going to see how the decoding will be for some of the instructions. The first one to consider is the add immediate, or ADI. For add immediate, we have the OP code given here. So we have OP code as 100010. Remember that the OP code that we use for our simple computer has 7 bits. Okay, we can also see it here. For the add immediate, we have it given here. Okay, and then based on the instruction decoder that we have here, we will have the control bits determined. So MB, MD, RW, MW, PL, JB, and BC are given using the instruction decoder as 10100000. Okay, then you can also see them here. We will see how these values for MB, for MD, RW, and so on and so forth are going to affect the way in which the data path is working. So if we move here, let me maybe make it a bit smaller such that we have everything in a single page like this. Okay, now you can see. For MB we have one. Where is MB? MB is over here. It is indeed the multiplexer which selects whether we receive the data from the register file or whether we receive the constant input. Yeah. So when MB is equal to 1, it means that the constant input will be considered. Constant input will be considered and it will be available on bus B. And we know that constant input also comes from the control unit. Yep. After 0 feeding, we have 3 bits coming from the control unit, and then there will be 0 feeding, and then we will have the constant input which will be used in our computations or in the execution of the instruction. Then for MD we have 0. MD is equal to 0. Max D, the value that we have for max D, is equal to 0, and it means that the result that we get from the function unit will be passed through over this bus, and it will be available, you can see the path, as the data input to our register file. Let me just clean this and then I will highlight them again. Okay, so till now we have considered MD. The next thing is regarding the RW, register write, which is equal to 1. RW is over here. It is set to 1 such that the data which is generated by the function unit, the result of the application, the result of the instruction in it, will be written into the register file at the address which is determined. Yeah. And then we have MW equal to 0. Memory write is 0. This is to prevent writing anything into our memory, and we don't want to do it for this instruction. PL is equal to 0. PL is here. It is set to 0, and it means that the value that we have for our PC will be incremented after the instruction is completed. And JB and JBC are also set to 0, even though they are not going to be used, yeah, by the branch control unit this time, because PL is already equal to 0. And then for FS we have 0010, and this 0010 for function select means that an addition will be performed on the data which comes from the two buses, bus A and bus B. And again, keep in mind that what we have in bus B is the constant value. Okay, so for bus B, we have this constant value. Since the control signals are set like this, then the instruction will be performed and we will have the constant value added to the data that we have in bus A, which refers to one of the registers with the address that we have for AA, and then the result of the addition will be stored or will be loaded into the register with the DA as the address. So that's what we get for the add immediate. The next one to consider is the load or LD. The OP code for LD is 0010000, and using the instruction decoder that we have, the control word is obtained as this. And again, if we check what we have in our data path, with MB equal to 0, the first one, MB equal to 0, the constant input will not be considered. So if you would need the data from B will be available on bus B, even though it's not going to be used. Then for MD we have 1. MD is equal to 1. MD is over here. When it's equal to 1, it means that the data that we have at the memory will be passed and it will be available as the data input for our register file. RW is set to 1 because we are going to write into the register file at the address which is determined by DA, obviously. And then MW is set to 0. MW is here, memory write is set to 0, and this is done in order to prevent writing anything into the memory. PL is set to 0. So PL is set to 0. This means that the value that we have for the program counter will be incremented by 1. And FS is set to 0. We don't do any, indeed, arithmetic or logic or shifting operation for this instruction. We just load, or in other terms, we just read from the memory, and load it into a register. Which register? It is determined by DA. So the data that we read from memory, where in the memory we read the data from, it is over here, yeah? So the address input to the memory comes from the bus A of the data path, and bus A is associated with the A address. So with what we have in A address, it is passed to the memory as the address, as the input address, then the data is available at the data out. Then using this multiplex T, mux T, it is taken and then it's written into the register file. The last instruction to consider is the branch on 0, BRZ. The OP code for it is 1100000, and you can see the control word over here. ME is equal to 1, FS is all zeros, MD is 0, MW, RW are 0. Now PL is equal to 1, and JB and BC are 0 and 0. Okay. PL is equal to 1, it is over here. So we will have a branch on 0. For the branch on 0, the Z status bit output from the function unit will be used. You can see that there is a connection over here. And it means that when we have 0 as z output of the function unit or z input to the branch unit equal to 1, then the program counter will not be incremented, but it will be it will be changed by an offset, okay? Because we have a branch, we don't have a jump. And where the amount of the offset will be taken from the instruction register. So you should remember that we just combine this bit 8 to 6 and bits 2 to 0 with each other as in the form of 6 bits. So over here we have 6 bits offset in the form of signed 2's complement, yeah, which could be then either positive or negative. It will be added to the program counter. Regarding the other control bits, we have MD is equal to 0. So MD is equal to 0, meaning that this line will be passed, even though it is not important for this instruction. Memory write is equal to 0 in order to prevent writing anything into the memory, and RW is also equal to 0 in order to prevent writing any data into any register. And JB and BC are also equal to 0 because here we have the branch on 0. So you can see that by providing the OP code and using the instruction decoder, the proper values for the control signals would be generated, and then they will determine for the data path how to function, yeah? How to create the path for the data, and then which operations to perform and where to store the result of the operation.